With the introduction of smart contracts and decentralized applications that offer high interest rates, Ethereum has set the standard for innovation in the cryptocurrency business. However, it's confronted with three key challenges. The first problem to address is the issue of limited data throughput. To put it another way, Ethereum has a transactional processing speed of only about 30 transactions per second. Due to the large number of people that use Ethereum, this processing speed is excessively sluggish when compared to other cryptocurrencies, which can process many more transactions in the same period of time. For example, the Cardano blockchain can process around 257 transactions per second, whereas Polkadot can handle up to 1,000 transactions per second, and Solana can manage 65,000 transactions per second. Because you're really bidding in an auction against everyone else who wants to be one of the 30 transactions, the Ethereum network isn't especially user-friendly. In a nutshell, this indicates that it's expensive. When I say spending $20, I'm referring to the cost of sending your friend $1 in advance. Finally, there are a few viable alternatives to the Ethereum blockchain for developers. Considering that all Ethereum projects are connected to the same network, they all have comparable throughput. This implies that they're all affected by the challenges that Ethereum is experiencing. But what if there was a blockchain that employed the same technology as Ethereum, but had more features, greater throughput, and had very cheap transaction fees? This is what we're going to talk about in this video. We'll go through what Polygon is, how it works, and the unique tokenomics of the MATIC currency. That's what we're going to talk about in this video. So, in 2017, 3 Indian coders set out to solve Ethereum's flaws, leading to the birth of MATIC, which has now been renamed the Polygon network. The coin is still known as the MATIC coin, despite the fact that it's been renamed to Polygon network. Polygon is a Layer 2 scaling platform that enables Ethereum-based apps to address the issues I described previously while simultaneously taking advantage of Ethereum security. Its main goal is to boost the use of DeFi tools and apps by linking blockchains together. Over 3,000 decentralized apps are being hosted on the network, with over 80 major brands migrating from the Ethereum main chain. Because Polygon and Ethereum are so similar, many developers who create valuable tools will port them over EVM blockchains like Polygon. They may expand their reach and usage this way. If you're not sure what EVM stands for, it's the Ethereum Virtual Machine. It's also the code that's executed by computers all over the world to carry out the blockchain's smart contracts. Polygon, like the Binance Smart Chain, Phantom, and a few other large networks, include the feature of EVM. They're all based on the Ethereum code, and because they all execute the same code, it's easy for developers to migrate their product to a different network and have it perform almost identically without making significant modifications. Moving on, most people associate polygons with the Polygon proof of stake claim, which is basically an Ethereum sidechain that employs a proof-of-stake consensus process. This sidechain has a few minor enhancements, but the most essential one is that it is much quicker and can process many more transactions per second. This also implies that it is more cost-effective for the end user. Technically speaking, the Polygon network is much more than a sidechain. Polygon's fundamental concept is to provide developers with user-friendly and versatile tools. They'll be able to accelerate Ethereum's transition to a multi-chain platform this way. To put it another way, Polygon isn't simply a single proof of the stake chain in the traditional sense. They're a group of blockchains that can help Ethereum scale. When they do this, developers will be able to simply design a variety of scaling solutions for Ethereum, such as a fully distinct set of chains, such as ZK rollup chains, optimistic rollup chains, or any other side chains that they choose. They are quite fascinating and imaginative approaches for compressing data and reducing the amount of space available on the Ethereum main chain. One method of expanding Ethereum's reach is through the Polygon proof-of-stake blockchain. In reality, Polygon aims to provide customers with a range of scaling alternatives. At first glance, Polygon looked to be very simple. However, when you look inside, you'll find that there's a lot more to it than what the common customer sees. For users like you and me, the term Polygon may be summarized in a single word. It works in a similar way as Ethereum, but with significantly reduced gas prices. Let's put it that way. The cost of transferring Ethereum from one account to another is now around $20. On Polygon network, on the other hand, it's less than a penny. Therefore, users will be able to check out the new apps and experience without having to worry about losing $150 as a result of a token transfer. Please take what you will from Polygon and Binance Smart Chain. which are the two DeFi blockchains that I personally recommend to beginner users, but you're free to take what you will from them. Let's go on to learn about how Polygon works. Powered by the Layer 2 scaling solution and the proof-of-stake protocol, Polygon serves as a commit chain to the Ethereum main chain and works as a backbone for the other Ethereum nodes. When it comes to commit chains, if you're not familiar with the phrase, it's a type of transaction network that functions in the same way as a real chain. Therefore, in Polygon's particular position, it works in collaboration with Ethereum to achieve its goals. It's the Polygon commit chain that combines the process clusters of transactions before passing the data back to the main Ethereum chain for processing. When a transaction is completed, Polygon uploads a single snapshot of the transaction instead of uploading an entire movie of all the transactions. This allows the Ethereum chain to understand what's going on without having to process a large amount of data. As a result, the Polygon network has the capability of processing up to 65,000 transactions per second. There will come a point, according to some experts, at which developers will host hundreds of chains that will work in concert with Ethereum to increase throughput of millions of transactions per second and enhance throughput to millions of transactions per second as a result. Polygon's architecture is built on a 4-layer structure that includes the Ethereum layer, security layer, Polygon network layer, and execution layer. Different Ethereum-based smart contracts make up the Ethereum layer. Staking, transaction approval, the interaction between the Ethereum blockchain, and several Polygon chains are all handled by these contracts. This layer is where Polygon communicates with Ethereum on a regular basis. Following that is the security layer. It also collaborates with Ethereum to provide validator services, adding an extra degree of protection to the chains. It's worth noting, however, that both the security layer and the Ethereum layer are optional. Polygon does not require them to function. The Polygon Networks layer is the third layer. It also is the Polygon ecosystem of projects and blockchain networks. Every project or blockchain in this ecosystem, in essence, has its own community. Blocks are created when local unanimity is obtained. The execution layer is the final layer. Polygon's Ethereum virtual machine is what it's called. Its primary purpose is to perform smart contracts on the Polygon blockchain itself. As I previously stated, compliance with the EVM improves the user experience for Ethereum chain developers and programmers. Let's look at Polygon's tokenomics now. A native token exists on the Polygon network. MATIC is the name of the coin, and it's been selling for roughly under $1, with an estimated market capitalization of $7 billion MATIC tokens as of May 2022. The distinction between these two figures is between tokens kept for staking rewards and tokens with a timed release schedule, which we'll be discussing later. During their initial private launch in 2017, the developers sold around 3.8% of MATIC's entire supply. Then, in an initial exchange offering, they sold another 19% of their maximum supply. You might be wondering where the other tokens are hiding. Developer teams own 16% of the supply. Advisors have 4%, stake incentives account for around 12%, and the ecosystem has 23% already. The Polygon Foundation receives around 22% of the revenue. The fact that MATIC tokens are currently being minted to reward stakers makes it a theoretically inflationary phenomenon. However, due to a limited supply, MATIC has decided to develop their own version of EIP 1559, which will be implemented shortly. It effectively indicates that the transaction expenses will be used up in the first place. Which MATIC is most likely to become a deflationary token in the near future? The Polygon team will hope that by then, the additional transaction costs that users give in order to prioritize their transactions above the basic price will be sufficient to maintain stake validators in the field. Thank you very much for taking time to watch. We hope you find this video entertaining. We really hope you've gained some knowledge. Above all, we want to see you in our next video.